Hello, I interrupted the last time's lecture saying a little about what are the geometric and other primitives that we have. So, I have also suggested that you look up the web to see what is it that people talk about as the basic primitives. And if you are a what you call just a somebody who has left school, or you remember what you did in school, in basic geometric they will tell you that there is a thing called a simple line, then there are various types of curves, and there are things which are very very familiar like a circle, an ellipse, then square, then various types of parallelograms and traditional thing like a cone. So, if you were to draw on them, one feature about all of them is that they are all simple, flat, two dimensional representations. So, I will go here and see. Now, I have just started a blank sheet, so that it is easier for me to draw on this sheet. We know the basic thing saying this is a point, okay, it is here, little difficult to make, but it is there, and then we have another point like this. And early on when you are learning various things, they will tell you that the shortest distance between 2 points is the line or the straight line. So, it did not come out well, let me take the edge as a reference. The shortest distance between any two lines are, I am sorry, the shortest distance any 2 points are the line. And next best to this is, instead of being a straight line, supposing you have something which is a curved line, this is called a, if everything it has an arc with a center, this one is a arc. This is okay, you would have learnt various things. So, I mean not too much of time need to be what you call repeated here, except what we require now. Often we come to various types of constructions. So, you see here we have a point, and this is where mathematical representation and simplicity have come, saying if you want to find out the shortest distance between this point and line, earlier you remember there were 2 points being joined together. Now, we come to the mathematical definition saying something which is perpendicular to this will invariably be the shortest line. I think this is very easy for you to make out, except that if you are interested you can go and look up again on the internet saying in real life and on earth, real life and on earth, because our earth being curved and spherical, there is no simple way of talking about a shortest line unless you want to drill through the what do you call part of the earth. So, there you end up with curves which appear flat when you look from the top. And I think, I do not know whether I have covered earlier, I have showed you the thing about how to make a picture of an earth made out of flat features. This is where invariably we will end up with things like, this is a beautiful earth which is actually it is a template, you can print the template and then try to attach these things together, and you get what started as a standard flat what do you call template, and you can attach all these things together and make a perfect globe. Maybe you had a chance to try this at when you are a child. There are so many other ways are also there, saying, as I think I showed you about the saying, how many pentagons and hexagons can you can make into making a nice round object. Now, at this point, while it is okay, we now end up with saying, why do you call something as a first angle and third angle projection? If you remember in the previous lecture, I tried to tell you saying, depending on, this is usually indicated in the title block. In the case of a first angle projection, in fact, the word projection is used here. Seen that itself appears a little a hint of saying, what do we mean by projection, or do you say a view? In the case of first angle, it appears that we shine a light here and then keep a piece of a screen which captures it, and when you do it here and then you do it here, you get two things. You see here, you get the larger circle and then you get the smaller circle which is visible inside here. So, there are some people, some proponents who imagine or claim this is only true projection which we can talk about. In contrast, third angle is slightly easier to understand, because what you see is what you draw. So, at this point, if you look at this frustum of a cone, this one comes here and the other one comes here, and similarly, if you look at this point and see here, you can imagine what will happen, what do you call, if you look at the object and draw here, you will get it. Imagine if you look at the object from here and draw, you will just have a large circle and a smaller circle with inside dotted line. In the case of this first angle projection, which for some reason I do not know how it has come about, most of Europe and parts of early mechanical engineering people continue to use this. That is, you keep a orthogonal thing and project it from here. Similarly, if you are to now project this on the other side, just look it up, okay, you will get it. Now, let me give you an example here. In the case of first angle, you will see that if you shine a light, and this is what will come here. But actually, even there also we have this little problem about saying, how can we call it a projection? Because in general, actually, if you were to shine a light here, you will just get a big block. You understand? You can get just a rectangle or a square, because the whole light is blocked here. So, in principle, it is not exactly like shining a light or anything, but if you now tie up these two things, you have seen this here, you will notice that if you were to do something here and project it, you will get what you are actually looking here, and that is presented here, which happens here. And there is absolutely no problem about something which because it looks like it is same from both the sides. If you shine something here, it will automatically appear here like this. And this view is where, now if I shine things from this side, if I shine a light and say a projection, I get a block plus I represent a dotted line. Okay. In contrast, the third angle projection appears a little more logical, meaning this is a top view. You see what you see on the top and draw here. You see whichever way you see, you look at it and draw here, and when you look at it, you will see a fully blocked thing, and then put dotted lines and then represent whatever you want. So, this in case, now that is a symbol which shows all this. This is a little bit of what you call pure engineering students will probably need it. So, do not worry too much about it. All you need to do is any time just remember this. This one is what you remember. In the first angle case of first angle, you actually look at something here and draw it here, and in the case of third angle, you look at it from here and actually draw it here. That is all that matters. Any time you have a doubt, you can just come back to this. These are all sort of people who need to be taught. I do not know whether really it helps. So, things like a bottom and left and right. If you remember early on in the lecture, I tried to show you this inclined plane and how these things actually, how are these represented, and even how something, the word, okay, first and second and first and third angle and all shown like this. You have seen this? Just have a look at it later on. Go to wonderfulengineering.com and then try to read it for yourself. It is very convenient, in fact, if we probably clearly write what it means and then similarly here write what it means and happily represent it here. So, if you orient it here, this is called a front view. If you see it from a top, it is called the top view, and when you look at it from here, this is called the right side view, because this is the right side. And you see one small top like thing with a small spherical thing being shown there, and you see here, these are all that new CAD representation has given us this beautiful way of representing things. Why I need to stress on this is, finally when you are using any of these drafting or any of these computer aided modeling packages, at some point or the other you will be asked to make this, because dimensions and all are not easily represented there in these things. Now, coming back to the old earlier representation what I was talking about. So, right now I will not get into the details of what comes where or anything. Just have a look at it, just have a look at it, because it is slightly different. And coming back again, I need to tell you about how to dimension these things. You see, from here to here, if you show a common dimension, we know that this total width of this object, the width of this object is same here. Similarly, if you see the height of it here, general things are common. And only one more thing is, if we were to show this dimension here, this is probably represented here. Depending on the orientation, depending on the way we present these things, any number of what all I have spoken a little earlier is all presented here. Just have a look at it, saying how these things are and anything. Anyway, that other thing is, I do not know. It is part of the advertisement strategy. Now, if you go to a real life project, we need to, if you remember, I had shown you about how to make a dummy, what do you call, first cut prototype model. Especially this is not for production. You understand, the first cut prototype model is not meant for production. It is only meant for you to show it to your other team members, saying this is what I am trying to work towards. Then you will end up with saying there are some people who have a simple product concept. I will avoid any what you call debate on these nomenclature at the moment. at the point. Just remember that what I am trying to convey, that what you also have in the mind is that whatever you have somewhere global and saying in the end I will probably make this, and just to be on the safe side, I mean more than just to be on the safe side, I am sure some of you may remember this, especially those of you who live in our side of the continent. It look gross if I tell you how to describe it. You understand? Now this one is a small personal tongue scraper which is used in the parts of the world which I come from. Now you have seen here suddenly that many variants are available. What I have shown you is a variant like this. You have seen this variant like this, which it is able to be used, but now this starts to be a metallic object. So often aircraft what do you call travel authority will not permit this in our airplanes. While it is somewhat okay, it is not that what do you call that object which is frequently used. So the next best is if you go to the especially the this is a very common these things called the tongue scrapers are very common. Now why I have shown to you is it is a very common thing. Some of you are familiar with it, some of you may not be familiar with it, some of you use them, some of you do not use them, and some the little higher expensive toothbrushes already have something which is built on the other side of the tooth head. The brush head is there on the other side, small variant of it has been made available. So it is not, it has been there forever as long as I can remember. Traditional, so we call it no Ayurvedic tongue made of copper, popularly used in the Indian subcontinent. What I tried to show you is that while I am not very sure how good these things are anything, the issue being actually after every food, I mean after every consumption of every dinner or lunch or any food, dentists in fact recommend that you clean your brush your teeth, and the people go to the next extreme saying no, also you use a tongue cleaner and then try to make things easier for you. I call this a product concept. You need to now explain to somebody this is what I am looking for. So obviously you talk about what are the functions it does, and this being a little about making prototypes for a product that in the initial stage we try to present it to our friends, and eventually it will be manufactured. And when you want to do the manufacturing, you will end up having to make engineering drawings. You understand, when you want to do the manufacturing, you have to make engineering drawings like what I have just now tried to show you about the two types of things. One is called projections, and I have spoken to you about it earlier saying projection is only a representation of how these objects will look like, how do you represent them. And finally, most how to say manufacturing continues to have things where a cutter moves, it moves horizontally in maybe two directions and then vertically. So we have the XYZ coordinate system, and related to the XYZ coordinate system is the all that this thing I try to show you about saying. When we now go ahead and see, while it looked okay, we end up with this large number of standards about general principles of how to make technical drawings. So, this ISO 128 incorporated what was done by DIN, Deutsche Industrienormen, and VSM, that is the they call French and Swiss norms. Then we have the probably ANSI, the American things, and then also the British standards regarding drafting practices. Again, the word drafting should be slightly different, because it is also, the word drafting is also used in connection with legal documentation, where some norms are there. In this case, it is all strictly related to only technical drawings. In this technical drawings, you see, we have basic conventions for lines, basic conventions application for leader lines and reference lines, general lines of construction, lines of mechanical engineering drawings. All these, a very large number of norms have been presented. Why do I tell you this? Because the design does not stop with you are just making a prototype or making something which works. You understand, no? It does not stop with very simple thing like making some prototype and making what you call functionally showing if it is working. What you need to do is present a file of technical drawings for production, and once the technical drawings issue come, we also need to make sure parts which are manufactured separately fit together. Follow. Earlier it was very easy, all we had to do is in the what you call previous workshop also I have shown you how we have made a part, and then after making the necessary concept and drawing, how the top cover was just fitted into that. But in reality, things do not fit easily. So, we end up with very important things like tolerancing things. What is a tolerance and how much allowance do we give? So, the thing which we are all familiar with is how a door, we have a huge this thing about how these things fit with each other. This, though it looks a little complicated, reality is this. I just a little while back I said the word door. If you see how a door fits into the doorway, you will notice that it is a slightly, it is not that easy to make sure that the door fits the door frame which is intended for. You end up with what is called a jamb. So, how these doors touch each other, and how do we try to avoid reworking when the weather changes. In the case of wooden doors, what will happen is that probably the frame is fixed already, or in our case no, it is, we call it a hole based system. So, the frame typically represents the hole, and then the part that goes inside, the shaft that goes inside. So, over the years several of these things have been represented such that they are universal. So, every time you need not go about the way the other previous, the what you call the craftsman carpenter is doing it. So, a lot of times where does the fit, type of fit that fits, makes two things assemble. So, if you have, let us say you have a bearing and a shaft has to go into the bearing, you have to make sure that the shaft fits snugly inside, or we make sure that it does not slip, because if the bearing is a roller bearing or a ball bearing, the friction is to be handled by the bearing and not by the between shaft and this. Similarly, let us say we have the housing in which the bearing has to sit. We need to have a perfect, right now I will not call it a perfect interference fit, which makes sure that on all conditions the bearing will not slip from there. In the case of wood, we have the issue of whether while wood itself may or may not expand the way we think about in the case of a metal, it swells when the moisture changes, and with the temperature lot of buckling and all takes place, uneven thing depending on this. So, when a door fits a door jamb, imagine this the door jamb and this is the door, and we always provide a small step and we give a gap, and the thing is the door should not go through, but then the jamb should not reduce the width that we have for the opening of the door. I have given you a normal real life everyday example, and in the case of our technical drawings, especially involving what are called fits, this has been standardized such that things like all these things which are given at the back, saying what is the allowance intentional difference between maximum material limits of mating points and what is the nominal basic size and deviation and so on and so on. No, lot of these things are to be considered. So, it is not enough if we just say we will just make it what I call the things just miraculously fit, nothing fits in fact. So, if you remember, I hope you recollect these things. What looks very simple here? We have a switch here, then we have various types of elements, and if you refer to the drawing of these basic components, there lot of technical data is presented saying what should be the opening size and all that. While when we first made this, it looked quite fine. This is easy, I just took a printout and then I stuck it on a piece of cardboard and then it looks fine. But when make it into a real life production, you will see that each part is made separately, and any cover is supposed to fit with any of the chassis elements. Similarly, any front panel is supposed to fit this, and then I also have a red screen glass on top of it, I mean not glass, what I call filter inside, red filter. So, this red filter should perfectly align with any openings which you have made at the back, and this whole front panel should go and fit with this item, and the stop cover should go and fit with this item, which we do not do it at the prototype stage. Earlier what was being done is you make a concept and you make a model of some sort or anything, present it to the workshop. Workshop will now think about all these things and they create a file in which various things are mentioned there, and usually you will have to work with that fabrication people to see which is the most important thing where you need to concentrate, because things do not naturally fit as we expect things. No, nothing fits. Murphy is at work all the time, and you would have seen it with, even if you take a very ordinary nut and if you take a screw and if you take it from a box of spares which you have at home, you will notice that none of them seem to assemble itself properly. There is usually some problem with either it does not go in or it is very loose. So, if you take a nut and if you take a screw and then put them together, especially taking from a bin, you will see we have a problem. That is how full standards about how fasteners are made have come about. So, we have thread standards which make sure that everything, any nut from a batch will fit any thread. Alternatively, if we have some part which needs to hold a threaded piece, we make what is called a a tap set. When you tap it, we expect that any screw which follows that standard, saying I say British standard Whitworth, or I say what you call some ISO M6, okay, or I say quarter inch any of the what you call American standards, if you have the corresponding the tap, you tap it and then the screw goes inside. While so fasteners are okay, you can play with it. When you come to things like gas threads, or when you come to things like what I call hydraulics items, the tolerances and all are extremely close, and not everything is what you call taken care of. At that point, things like pressure, variation of viscosity of the materials, and the temperature variations, all this come into picture. Fortunately for us, in the case of our simple electronic enclosures, we need not worry too much about it, and usually after you make your whatever first level drawings and then pass it on, there are other experts who work with it. This is where I feel which I thought I will stress, first time when you make the drawing, if you consider all these items, if you make a proper solid model, and that too if you make a solid model with any of the little more advanced packages, you can directly specify tolerances and you can directly specify fits, and usually there is a way of checking back in the whole system, by which it will tell it, the package will give you a prompt saying yes, this is feasible, or saying no, somewhere you are exceeding something. So I will stop here, I will continue next time. In this lecture what I try to cover you is there are certain standards regarding how to mention the features that we want. The simplest features are the lines and the shapes, and even in a flat sheet, when you are representing something for somebody else to understand, we have a common language which is a highly technical language. So in fact nobody writes here no, something needs to be plus 0.5 mm or plus 2 mm and all. Instead they will specify a fit saying this is a JS fit, or this is called a H14 what you call N6 K6 fit, and so on like that. So N6 refers to a particular range of the hole, K6 refers to a particular range of the shaft, and when you push them together, so there is in fact in ISO, which I will come back some other time, there are a list of types of fit that are possible have all been standardized, saying if you call that as some JS system, or if you call it some H something and so on. So all these have been standardized, and they usually mechanical engineers reference books will give you what you need to do. And why all this is required is, it is not that you keep on assembling the parts, you can't take one bottom and try to put the remove something and assemble it and so on like that. For everything you have go, no go gauges. So these gauges have all been standardized with respect to the tolerances and fits that we specify, and this is where a little what you call unnerving, that you need to add all these things to your drawing at the drafting stage itself. I will continue with this later with a little coming back. So thank you.